Hi, I'm Michael Richardson, America's Automation CE, and this is Automating PanOS with Ansible. So the official Ansible collection is Palo Alto Networks.panos, and as of February 2021, the current release is 2.5.0. This is an open source project at Palo Alto Networks that's maintained by our developer relations team. The Ansible collection consists of 90 plus modules for PanOS firewalls and Panorama, and they all operate on the device's XML API, which is something we've had since PanOS 3.0. They all utilize the PanOS Python library, which is a general library for manipulating PanOS devices using the Python language. For your capabilities, you have configuration, which is the majority of the modules that will let you add, edit, delete config elements. And these are, most of the high-level objects that you would think of in PanOS. Address objects, rules, network interfaces, VPN tunnels are some examples. And then you have operational commands, which is most everything that isn't configuration related. So you can pull info back from a running device, you can validate config, you can reboot a device, you can upgrade the software or upgrade the content. And this is an important distinction for what you can accomplish using Ansible that you can't accomplish using Terraform. So here's an example of just creating objects using the PanOS Ansible modules. The first thing you'll notice is the connection local up there at the top of the playbook. And it's important to note that these modules are run on the control node, which is the machine that's running the Ansible playbook, not on the PanOS device itself. So typically the way that Ansible modules work is they copy Python code to the individual device and execute it there, which is not something we let you do with PanOS. So these modules run on the control node and talk to that device's XML API. You'll also see the provider dictionary, which contains all of your connection details for the PanOS device. This is where you specify the IP address, username and password, or API key if you want. I'm using the dictionary called device in this playbook to feed to the provider option for this module. Here's an example of a full policy. I've had to collapse sections of this to be able to fit it all on this slide. This shows interface configuration, as well as zone creation, service object, and security rule. So all of the Ansible modules will also let you create config elements in a Panorama device group or a template, depending on what type of object you're using for that module. Here's another example showing VPN tunnel creation, which is a great example of something that maps well onto an Ansible playbook. VPN tunnel creation consists of a lot of individual components in PanOS, and it has easy to forget parts of it or checkboxes that you don't want to think about every single time. And creating VPN tunnels is something that is very prescriptive, and you can reduce the amount of time that it'll take troubleshooting if you don't miss one of these steps. This is also something that would be very nice to hand off to another engineer on your team and be able to execute it the same way every single time. Here's an example of operational commands using the PanOS Facts module. And generally speaking, you can get a lot of good data out of this particular module. You can gather information about the running system, sessions, interfaces, HA status, routing, virtual routers, virtual system configuration, and then the config itself out of this module. So another one of my favorite examples of what you can do with an Ansible playbook is upgrading PanOS devices. This is another really administrative time sink that works really well as a playbook. You don't want to have to remember during your late night outage windows if you made a config backup first, or if you checked failover correctly, or other things like that. Again, this is something that is very nice to be able to hand off to another member on your team, whoever's happened to be upgrading that particular firewall. Make sure that you do it in the same exact way. I've got, and this is a single node upgrade playbook here, but I've got an HA upgrade example linked to here in a repository of example playbooks that I'll share at the end. So two modules that are really nice to have if you need something that is not something that is supported in the Ansible collection right now are PanOS op and PanOS type command. PanOS op will let you execute any operational command that you want and get back the result as both XML or a JSON format. And then if you use PanOS type command, you can send any raw XML API command to the device. So if it's a config element that we don't have a module for, or if it's something that like you want to create a backup here, which is just one command that you can use using the op command, both of these are really good to have in your toolbox. So for some additional resources, we've got the official GitHub repository for the Ansible collection, and then a repository of Ansible playbooks that I maintain for examples. Now, I'm going to show you some two examples of running particular playbooks. VPN tunnel creation to an AWS private VPC, and then upgrading the software on a PanOS device.
I wanted to demonstrate two playbooks from the Ansible playbook repository I mentioned in the presentation. The first one is awsvpn.yaml, which configures a VPN with an AWS private VPC. I really like this as an example because it's a non-trivial bit of configuration. It's got two IPsec tunnels for redundancy and has BGP running inside to exchange routing information between the VPC and the firewall here. So I've already built out a firewall in AWS and a private VPC with a Linux instance inside it. So I'm going to go into the firewall here. I've set this firewall up with a basic policy, but we don't have any sort of dynamic routing configured. We don't have any sort of IPsec tunnels configured. So I'm going to go back and I'm going to run this playbook. And all I'm really feeding it is a YAML file with credentials for the PanOS device that I'm going to log into and the AWS VPN ID. It's going to go ahead and run, and this is going to parse out all of the details about this VPN using the EC2 VPC VPN info module. And it's going to set that as fact, parsing it out with a parse XML filter. And it's going to do all the configuration for the PanOS device. And that's going to take a little bit. All right, so it's done. And if I go into the firewall GUI here, I'm going to refresh. So it's created the IPsec tunnels, and they're up and running. And if I look, I've configured BGP on my default router here. And I'm exchanging route information with the VPC, which is this 172.16.00/16 net block through BGP and through my tunnel interface here. And I can go to the BGP tab and see that I'm forwarding routes, and I'm also transmitting routes out to that private VPC. So I've got a Linux box here behind the firewall. So what I can do is I can actually ping to a host that's running in that private VPC. And I can ping it. I can actually SSH to it. And we can connect. And if I go in here, you can see that the traffic is going through the tunnel. So the next thing I wanted to do is run the upgrade single.yaml playbook. This is a very simple playbook that's going to just give us a backup, run a backup of the config on the device, and install a new version of PanOS. This is a very simple playbook, but it can take a little while to run. So I'm going to cut out a section here so that we can speed up this demo. I'm going to upgrade this. The firewall is running 9.1.3. We're going to upgrade it just a point release to 9.1.4. Okay, so that took about 15 minutes to run. I'm going to go back in and I'm going to refresh the page because this is timed out. And after logging back in, the firewall's been upgraded to 9.1.4. And you can see here in the system logs that our tunnels have come back up. So we're rebooted and everything's good. Thanks.